we know that an object starts from rest, right? And it has a mass of m. So the object is at rest with a mass of m. Now we have to find the velocity at the bottom of the inclined plane. And we know that there's no friction acting on the body. So we can find the acceleration by the following equation. Acceleration of the plane is equal to the gravity times sine of the angle. So, and once we have the acceleration, we can find the final velocity by the following equation. Delta V, which is the change in velocity to the second, it's equals to 2 times the acceleration times the change in position of the object. So we know that the initial velocity, since the object was at rest at the beginning of the movement, it's going to be 0. And then the position is going to be, the initial position is going to be also 0. Now we just do the following. Velocity is equals 2 times, we know the acceleration from this previous equation is gravity times sine of the angle plus 3 or times 3, which is the change in position of the object. So velocity is going to be equals to 2 times 10. The sine of 30 is going to be 1.5 times 3. So the velocity is going to be equals, this is to the second, velocity is going to be equals to square root of 30. So for part B, they're telling us that the dynamic coefficient is 0.3, and we have to find the velocity when it arrives to the bottom of the inclined plane. There are certain forces acting on the block. We have the normal force, we have the gravitational force, and we have the friction acting over the block. Okay, so according to the second law of motions, we know that the sum of the forces acting on a body are going to be equal to the mass of the body times the acceleration. We're going to find the acceleration first so we can find the velocity of the object. So, we have the gravitational force acting on the body, and we have the friction force. So we're going to forget about the normal force. We have the friction force as well. And that's going to be equals to the mass times the acceleration of the block. So, let's find the friction first. So friction is going to be equals to mg times the normal force. And a way to find the normal force will be normal force is going to be equals to mg times cosine of the angle. Okay, so friction is going to be 0.3 times mg cosine of the angle. Let's plug in the values into mg times the normal force. And a way to find the normal force, 0.3 times mg cosine of the angle. Let's plug in the values into this equation. So, mg sine of the angle minus 0.3 mg cosine of the angle is going to be equals to the acceleration over the mass. Now from this we can simplify the mass of the object here, here. So it will be g sine of the angle minus 0.3 g cosine of the angle equals the acceleration. So this will be the acceleration. Now, of course, we will use the same equation we used before to find the velocity, which is delta v square equals to 2 times the acceleration times the displacement. The initial equals 2 times the acceleration, x minus x initial. Square is equal to 2x 2 times the acceleration which is the acceleration is going to be g sine of x, g sine of the angle minus 0.3 g cosine of the angle. So all of this multiplies by displacement. This will be the final velocity.
So in the working energy